Okay, so number 10, you guys can find your final answers. This is the given information. We have our final angle B. I'm just going to point you in the right direction. I'm not going to say a lot. Just pointing you in the right direction because there are lots of numbers up here. Number 30 was a little weird. I imagine we might have some questions on this. But they were using the right triangle. I think Nathan and I, were we talking about this one? Nathan, or was it a different one? It might have been a different one. Oh, okay. Never mind. This is just an impossible one, right? Maybe that's it. This is just an impossible one. Sorry. Number 44, just plugging into the area formula, and we get 4.5. Number 52 was a bit of a dilemma as far as a picture goes. But if you took your picture and you thought about things like supplementary angles, you would have been able to fill in or parallel lines with alternate interior angles congruent. Even though it was weird, there was a way to fill in what two angles of this triangle would be from the extra information. Filling in the holes. Hey, there's a cool allusion to that. Extra biblical information can sometimes fill in some of the gaps of what you don't totally. Anyway, there's a really cool line of thought that you guys don't really probably get. But anyway, you can fill in this triangle. You can have your side angle side. And at that point, it's an easy law of cosines. But without that, you might have been thoroughly lost. So they had to use some geometry. Once again, the geometry they used was alternate interior angles being congruent. And they used, I think, supplementary angles for this one. They might have given you the bearing, and then you were able to get to 70 degrees. But if you guys want, you can grab down the final. And then if you guys need some more information, you can feel free to ask. Number 56 was a bit of a weird one. But let me try to zoom in because I know that it's a bit... nope, that doesn't help at all. Let's go here. There we go. The first picture with the Leaning Tower of Pisa and then the observer looking straight up, or the bottom, I should say, looking straight up. You could make a right triangle. And that right triangle, you could go ahead and solve for this angle just by using a simple sine function. And that's how much it's leaning. But then the rest of it, B, C, and D, gets a little bit more abstract. You can actually use the law of sines, given all of your pieces of information. I don't think they labeled the triangle for you, so maybe you would have had different variables. But they were just basically asking, and this is a really important skill in physics, in physical science, which would have been a little bit earlier. I think even in chemistry to some degree, of solving for different variables. I think it's a skill you worked on in Algebra 2 and in Algebra 1. If they wanted beta alone, just how do you do that? Well, you multiply sine inverse of both sides, something that you guys have been doing a lot with law of sines. It just looked weird because you had lots of variables. But they just wanted you to go ahead and get that beta alone, rearranging the law of sines. And once you got that beta alone, then you were actually, like the previous problem, able to use some geometry, that angle that you already found, the leaning angle, and say, wait, if that's how much it's leaning, then this angle is 90 plus the lean. So I know this angle, and I'm able to, from the three angles of a triangle adding up to 180, I'm able to make an expression for the other angle and say 180 minus the 90 plus the lean will give me an expression for beta that I can actually plug into that beta spot with a rearranged law of sines getting the side by itself. And then I can actually, crazily enough, get an expression for D in terms of beta alone. So this one we were kind of stuck. We have 1, 2, 3 variables. This one we only have 2. And with those 2 variables we can throw it in the table. Bless you, bless you. Those 2 variables we can throw it in the table. And then last but not least, number 62. You wanted to find that third side of the triangle. If it was a right triangle, that would have been 5. And then kind of judge based on 5. Okay, if it's bigger than 5, if it's less than 5. Or I'm guessing we might have a question on that one too. It's just a couple seconds for you guys to see it. I'm going to freeze the screen as you're peeking at it. The 2 big numbers in number 62 was the length of the one side, which was 3, and then the length of the hypotenuse, which was 5. With that, I think we have the final even checked. I do have the book open over here. So now's the time for everyone, whether or not you needed to check those evens. If you have questions on last night's homework, remember when we come to grade the homework spirals, if we see empty problems, we can take off points because now's the time in class to ask me things that are either empty or you marked wrong and you need to fix. So, yeah, Emma, what we got? Yeah, definitely. That's a weird one. Anything else besides 62? I think because that was the last one.
35.
35. Anything else? 35, 62. You get? Yeah. Okay, so number 35, let's start there. Because they're both super similar problems and they're tricky in different ways. To be honest, I think this one's solving for B. I think 35 is the trickier of the two. So let's go talk about 62 and then we'll come back to number 35. And of course the computer is going to black out on 62 and not show me what's going on. Okay. Emma, sorry, can you help me out real quick because the computer's being weird? What was given to you in number 62?
You were given a triangle with the right triangle.
Okay. Like an acute-ish triangle.
Yeah, and then the hypotenuse was 5, and then the other, that bottom angle, it just said 0, 0 on it. It didn't really give us the angle measure. And then on the top, that was 4, 3. And then you had to find A, which is across, like the angle, yeah, right there.
And they were asking you for, can you tell me the order? Was it 0 solutions? Then 1, then 2?
Yeah, I think so.
Okay, this all has to do with SSA from yesterday and the swinging side. It all has to do with the swinging side. Now we do know that, which makes number 62 easier than number, Lucas, 35, right? What makes it easier than 35 is we know that this is set and we know that this is set. What can change, what can swing is this A, depending on its size. Now, here's a question. If A was, so we know that this is 4. And if it was a right triangle, this would be 3. I'm trying to indicate that A could be straight up and down, or A could be out, or A could be farther. If A was equal to 3, if A was a swinging side, if A was equal to 3, it would go straight down, it would hit. But if I tried to swing it, guys, would it hit anywhere else? No. So if A equals 3, that's one possible triangle. That's not the only one possible triangle. Why am I also going to say A greater than or equal to 5? You see it? A greater than or equal to 5. Right, it can go out however long it wants. There is nothing limiting A. It can go to infinity, technically. It can be 5, 10, 100, 1,000, a million. I think that's going to be a very flat triangle, and a very wide triangle. But A can be, however, if it can swing, it can go and be as long as it wants. There's no angle restriction about what this is. So I know that A can be greater than, meaning going to infinity, but why did I know that 5 was the limit? Yeah. If A is 5, if it was 5 out, if I tried to swing 5 in, it would hit the other side. That would just be a straight line. There would be no triangle, and this angle wouldn't be in it. So if A was 5 and I tried to swing in, wait a minute, why am I talking about swinging in? Well, remember, if A is in between 3 and 5, if A is bigger than 3, which can only hit once, if it's bigger than 3, boom. But it's not as big as 5. It can swing out and hit, or it can swing in and hit. But if A ends up being 5, it's going to try to swing in, and it's not going to make a triangle. So if A is between 3 and 5, then it's going to swing in or out and make 2 triangles. So then what's left? What other numbers are there? The 4's here. 5, 6, 7, 8, 9, 10's here. Where's 2 or 1 or 0? What happens if I have something shorter than 3? It doesn't hit. Something shorter than 3 mathematically, shorter than 3 is never going to be able to make a triangle, so it's not going to work. Shorter than 3 is not going to work. Now, Lucas, number 35, why was it harder? Similar question. Because you're still trying to figure out, I think it's at 0, 1, 2 solutions.
Yeah.
Okay. You're still trying to figure out 0, 1, 2 solutions, but instead of them giving you the B side, technically that would be the B side, they've given you the A side, which makes everything a little bit worse. So number 35, let's see, we're still trying to figure out our 0 solutions, our 1 and our 2. But what was the given information in 35? I think I have it up here. All they give me is 36 degrees and 5. Oh, it's backwards, sorry. We'll get it. So that's A, that's B, that's C. Okay, so angle A was 36 degrees?
Yeah.
What was side A? Can I still draw a triangle? Yes. Can I still think about this? Yes, it's just not going to be quite as straightforward as the other one. So 36 degrees, bear with me. Is it okay if I just kind of do like a 90 and then 30 and 30? Okay. So I have my 36 degrees, and this could go on for however long I want it. Because B is the guy I don't know. I don't know, he could go on forever. But I know that A has to be 5. No, this guy needs to be 36 degrees. So I'm going to go ahead, and like I did yesterday, I'm going to come up with some random unit of measure that fits on my board where I can have a measurement of 5. Let's go ahead and get that A is 5, because I know 36 degrees is set, it's solid. And I know, let's just use 5 centimeters. 1, 2, 3, 4, 5. Okay. All right, so I have a length of 5 right here, and this is my side A. Now, I'm going to go ahead and make this straight up and down, because that's what we did here. We figured out the straight up and down, and he was kind of a guy that got used in every single answer. So I'm going to have, oh, well, this straight up and down is not a right triangle. This straight up and down, let me go ahead and move all this down. So we're going to move this down a little bit, just for the sake of argument. Let's move this out just a little bit. So now it's going even farther. Oh, undo. Okay. So I'll just go out even farther. There we go. I'll move them back and down a little bit. So this 5, if it was a right triangle, would be the shortest distance between 2 points. Now hold on, I need to figure out where my horizontal is. My horizontal is right here. Where would this 5 have to, let's see, right, there. Okay, this 5 would make a right triangle if, oh wait. This B for the right triangle, I can totally solve for that using what trig function? Which one? Just sine. Good old fashioned, it's a right triangle. So I can figure out what this B is if I go ahead and just do a quick sine setup. Opposite is 5. The unknown B would be, there we go. I could multiply up the B, divide the sine. Someone get me that decimal if you haven't already, but I think a couple of you already did it last time. 5 over sine 36. Nathan, what did you get for that one? I remember 32, but I don't remember 5. I'll just put the 5 over sine 36. Anybody throw it in their calculator? I'm supposed to have calculators out. Let me see if you got. Oh yeah, you can go. You got it? Oh, Vanessa. 8.5. Someone back her up real quick, but we're going to use 8.5. Good. Thanks, Kayla. So 8.5. If B is equal to 8.5, haha, look at, I started off just like I did the one for Emma number 62. 8.5. Okay, now hold on. What if B was bigger than 8.5? The right triangle B is 8.5, but remember, B can keep on being bigger or shorter. I'm allowed to choose B. What if B was bigger than 8.5? Is that good or is that bad? Yeah, why would it be bad? The 5 wouldn't touch. The shortest distance between any 2 points is a straight line. He won't hit, even if I swing him. So, oh, hey, we just got another answer. If B is bigger than 8.5, no, it's impossible. Okay, so what if B is less than 8.5? What would happen if I bring this guy down? What would I have to do to make a triangle? Swing. I could swing him out make an acute triangle, or I could swing him in and make an obtuse triangle, but only for so long. So 8.5. Only for so long. You guys use what we did. When does it become too much and I can't swing in? If B was 5, I would try to swing this guy in, and all that would happen where is B is 5? Here he is. If B was 5, which would be right here, which would be this marker. Oh, that's not what I wanted. Where are these guys? Oh, there we go. If B was 5, he'd be right there. And I would try to swing in this side of 5, and it would just match, and it would just be a line. Now, guys, I could still totally swing him out. And I could still make a triangle going out, but as soon as B is equal to 5, I try to swing it in. And I'm like, yay, there's 1, but not 2. What if B was 4? Well, I could go out, but I couldn't come in. What if B was 3? I could go out, but I couldn't come in. So that just finishes off my entire answer, because that's the other times I'll only have one solution. If B is in between, well, I guess you could say B is less than 5. And we're kind of assuming that B can't be 0. If B was 0, well, it can't be a triangle, because I don't have a side. I think I put them in the right order. Sorry if they're a little bit out of order, but the 0 solution, 1 solution, 2 solution, it's your A, your B, and your C. Lucas and Emma, excellent questions. They were 2 very tricky problems in similar but different ways. All right, let's go ahead and go look at that law of cosine. Some of you guys have already been working on homework. Some of you guys wrote down the formulas yesterday but haven't had a chance to practice them yet. Everybody, calculators out and open, because we might, we will have to use an inverse trig. And what sometimes happens with inverse trig functions? Errors. Errors if you don't put in the parentheses right. Errors if you don't put in the fractions right. But also errors sometimes when you get impossible information. Did you guys have any impossible triangles last night? Yep. So because of that, I want to make sure that our calculators are still good. I had some honors kids when we went through this that like 2 days later were like, yeah, my calculator hasn't worked for anything. I'm like, and you haven't asked me yet? Like, make sure your calculator is working if you're not getting any of the answers. Sometimes error is good. It means no. But sometimes you're supposed to be getting the answers. So if they're not matching up, you guys have been doing a great job. You guys have been doing a great job of getting my attention and being like, hey, something's wrong, and let's just fix it right now. But guys, where are we going to have to be? Look at these 6 formulas. Remember, each of these sections has a law, maybe 6 of them, and has an area formula. So we're going to try and get to the area formula before we're done. Here's the laws. We're going to practice them a little bit. We'll go grab that area formula. Then you're good to tackle this homework for tomorrow. For Friday, spoiled rotten, man. Okay, maybe we can do some extra examples tomorrow. Maybe we won't get to the area formula today. But as you guys look up here at the law of cosines, where will you need to do inverse trig? Yep. Because these ones, I don't think they care about the cosine of A. What do you think they actually care about? The A and the B and the C are missing an angle, right? So if it helps you, it might be helpful right now to put in like, hey, cosine inverse, and hey, cosine inverse. And you can do that for every single formula, because to get angle A, cosine inverse of the other side. To get angle B, cosine inverse of the other side. To get angle C, cosine inverse of the other side. And if you're one of those who are like, I like to memorize as little as possible and then just figure it out, technically, you don't need to memorize. You don't need to memorize the alternative form if you can rearrange formulas really well. Last night in the homework, there were a couple of different places where you had to solve for beta or you had to solve for D, and you had to rearrange formulas. If you can rearrange formulas really well, you could technically plug into, let's just say you're missing angle A, but you have everything else. You could plug in everything else and say, I need to get to U. Well, what would you do? You guys tell me. If it was an equation, he's missing, everything else is filled in, how would you get him along? subtract this guy and this guy, right? So you would have a squared minus b squared minus c squared equals. Now what would you do to get him over? Divide by what? I can divide by the -2 and the b and the c. Oh my goodness, cosine A equals a squared minus b squared minus c squared all over. Oh, that's not the same formula. All the signs are flipped. Oh. Isn't this dividing by a -1? Can't I say dividing by a -1 is the same thing as multiplying by a negative? Can't I distribute and I end up with a positive b squared, a positive c squared, and a negative a squared? Long story short, you wouldn't even have to do that if you were solving. If you're really good at rearranging, you could technically just memorize the first three. And if you're missing an angle, move it all over. But these alternative forms are because, well, let's be honest, we're lazy. And if we can go straight to cosine of A, it's a lot nicer than having to move things over. But once again, if you're one such like, I want to memorize as little as possible. Sorry, Diego. Technically, you don't have to memorize those 6. But why do I put SSS and SAS? Because law of cosines is a great law to use if you have at least 2 sides. Now, the ambiguous case, you're like, oh, okay. He's probably easiest with law of sines. But any other time you have at least 2 sides, whether a side included angle side or all 3 sides, this is the guy to go to. But just like we did before, if I were you and you're using all 6 formulas, make sure if you are analyzing a given problem, I see that hand come. Make sure what's on the left is what you're missing. That's the easiest one. If you're missing a side, use these 3. If you're missing an angle, use these 3. Maybe make a note to yourself. That's helpful. If you're missing a side, get that side on the left. If you're missing an angle, get that cosine angle on the left. Emma.
Can you go back a slide to all the math you just did?
Oh, yeah. Hold on, I have to undo because I just deleted it. There you go.
Why is it when, like, in cosine A in the second formula from the bottom, it says a squared minus b squared?
Oh, sorry. My mind is
Oh,
really
sorry.
short. No, it was my bad.
I was just
It was
confused
just
because I didn't know if I was multiplying or
You're
not.
like, that's a good thing. Yeah, it was minus from back up here, and I subtracted. I just stuttered already. Good question. Yeah. So eventually, and even in this homework itself, guys, it's gonna say, here's some stuff. Find me all the extra, or find me the missing parts of the triangle using whatever law you want. I think it's towards the end of homework. Using law of cosines or law of sines. Can you just think, if you were given side, 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 why wouldn't we just naturally want to use law of sines? You've done it long enough. Why is that a bad idea? We don't know a pairing, right? Law of sines, don't we want an A sine A or B sine B or sine C, C? We need an angle with a side. Do we know any angles? We know no pairing. Law of sines isn't going to work. There's no way to go about it unless we can use law of cosines. Now, guys, hold on. If you're looking at your formulas, are we going to use an A squared, a side squared equals, or are we going to use a cosine angle equals? Because we're missing an angle. So you guys just need to tell me which angle do you want to start by solving for. Oh, never mind. Let's just follow the directions. So, cosine A, because I don't want to solve for all of them if we don't have to. Cosine A. Now, memorizing the formula takes practice, so kind of thinking through the formula itself. Cosine A equals, yeah, if it's the changed form, it'd be a squared minus b squared. If it's the me making it, a squared minus b squared minus c squared over -2bc. But if it's the book form, they're like, too many negatives. Let's just do the other two guys, kind of like Pythagorean theorem a little bit. But not Pythagorean theorem because he's not a right triangle. So then we have this extra, oh, there he is. Does that look good? Just making sure I'm doing it right.
Yeah.
So I can say from that angle A is going to be cosine inverse because I love plugging it in all at once to my calculator and not having to like keep track of all these little baby steps and messing up with one big old, how do we make a big old fraction in our calculator? Okay, if you're not using alpha y equals, or someone found a shortcut, I think it's alpha x, is that what someone said? I think alpha x, check it. Someone said it was a shortcut. If you're not using the fraction, you have to put parentheses around your numerator or denominator this time. I'm not kidding. Yesterday I was kidding because law of signs, it didn't matter. Now it doesn't. If you're using a division sign for a fraction, you have to put parentheses around your numerator and denominator in the cosine inverse. Otherwise, use the fraction.
Why would you use cosine inverse?
Because I want a, sorry, so I didn't show the work, I just kind of skipped it. But if I do cosine inverse, remember that's how I undo any trig I ever did. And then I just need to do it to the whole side. So if you're not using the fraction, you have to use parentheses because PEMDAS will totally break down. It's going to do adding and subtracting before your little division. Anyway, it's going to mess up. But in this case, we just need to get our numbers in the right place. And as long as we do, it's a simple, might take a little bit of time, but one single plug and chug of B. And if you guys notice, it's not even so much about memorizing all those letters. It's more just understanding. To get to angle A, I use the other two sides, B squared plus C squared, minus that bookend side, A squared, all over 2 times the other two sides. That's how the formula always works. And then we can plug and chug. And as long as you plugged it in correctly, make sure you get an answer now, or else homework's going to be so sad because your calculator, either you're doing the parentheses wrong, or you're doing the fraction wrong, or you're probably not in radians anymore. You're probably all in degrees. But make sure your calculator's working for you. Once again, if you have one of these types of calculators like Diego yesterday and the fraction thing is not popping up, if you just drop by, leave me your calculator, maybe even after class, I can go ahead and hook up mine with yours and upgrade your operating system and have it ready for you by lunch. As long as everything works. Sometimes the calculators get a little mad. Yeah, Vanessa, you have a question? Oh, it's not working. Okay, how are you plugging it in? Your parentheses, right? Oh. Yours, you have to, and this little parenthesis is for the cosine inverse. So mine, it's like that first parenthesis. Since we put in the fraction thing, you have to hold in. See how I put the little parentheses around the numerator? That's like the blue block. You need to get a parenthesis around the whole numerator. That's good. Then you division. So your whole numerator group. Yeah. So now do the same thing with the division too. All right, have you guys gotten it yet? What do we have for our angle A? 82? 22. Oh, 22. Point what? Now, if you needed to keep going, let's strategize. Do you have to use law of cosines? No. What's the next thing that you might go searching for? Because this is angle A. Now we need to solve for angles B and C. Do we now have a pairing that we can use law of sines for? Yes. But what am I going to ask you to do? Use the rounded form? No. Use the long drawn out form just to avoid any error. You could totally go to law of sines now and finish off the problem. But pause. Could you also go to law of cosines? Yeah. Because now you could go ahead and do the same exact thing for cosine B, cosine C, and you already kind of have it plugged in your calculator. You can copy and paste and just change where the numbers are. It might even be easier. But in your head, some of you are like, law of sines, please, let's just go back to that. So what changes if you have an angle and two sides? Sid, go ahead. Say it one more time. Oh, copy and paste, use your scrolling up, your scroll up. And when you scroll up, anything it selects, if you hit enter, it will copy it down below. And then if the up arrow doesn't work, some of the calculators, if it doesn't have the fraction thing, you can also use second enter, and it can go back and see. What are we solving for? If I need to solve the triangle, we have to figure out the starting point. What's the first thing that you guys think we'd solve for? Yeah. Wait a minute, why not use law of sines? Because B over sine B, oh, we don't have another pair. We don't have a pair that would work. But this one, guys, we'd be using the other formula, and the other formula is b squared equals. Yeah? The other formula is b squared equals. And in this one we have our kind of similar to the other one, kind of Pythagorean theorem-ish. Did I do that right? Yeah. Minus 2ac cosine of b. We use the one that will bookend what we're missing with what we have. We have our angle. Quick reminder, if you guys have your calculator, where's the minutes again? Second angle, right? Second half, so you can find that little minute button and put that in. Or you could just be lazy like me and do like, hey, it's 75 and 20 divided by 60. I can just convert it in my head. Either way. But guys, just remember on this one, when you get to the very end, what are you going to have to do to both sides? So why not just throw in the square root from the very beginning? You could go ahead and solve for that side b by plugging in your a squared plus c squared. I'm just going to finish off plugging in so that I have it in the notes, but you guys are good to go. In the sense of you already saw, we get to spend a little more time in examples tomorrow. Start tonight. I'm going to ask tomorrow if anyone got stuck in homework, and if so, I can help you out in class. Anybody else want their calculator updated? Anybody else want their updated?